Hello students, and welcome to section 9-4, solving quadratic equations using square roots. We're going to start off today in example 1, as it states, solve equations of the form x squared equals a. For part A, it says, what are the solutions of the equation for x squared equals 49? So this is a quadratic equation. Okay, and as it's is highlighted here above, x squared equals a is the relatable form. So a in this particular case is actually 49. So let's take a look. As it turns out, you can solve this quadratic equation as easy as by square rooting both sides. So solve by inspection, it says first, denoting that x squared equals 49, wherein x squared, if you think about it, that quantity has a number like 7 and -7. X, for example, this variable. 7 and -7, both on their own individually squared, will in fact yield 49. Now, the title of the section today is by square rooting. As it turns out, you are going to be able to square root on your calculator. I would argue just as easily as follows. So if you take the square root of 49, you're going to get 7. Now it turns out 7 is not the only answer. As we kind of go backwards, so to speak, 7 squared is 49, not surprisingly. But what about -7 squared? In other words, -7 times itself. It should end up also being 49. So by inspection, they're saying, there's two answers to this problem. 7 and -7. Okay, the plus or minus is necessary in a problem of this nature. Anytime we, as you're about to see later, more specifically, when you square root both sides of an equation, you'll have to include the plus or minus. The answer in this case is just that, 7 and -7. So there you go. We'll go ahead and move forward. It says, what are the solutions of this equation? So it's a similar type of situation. Now here's the problem though. The question at hand has an a value that is negative and not positive. So if we again proceed by inspection, maybe your instincts tell you, okay, well, what if I did the square root of 121? Now it turns out 121 is a perfect square. If you take the square root of 121, you get 11. Here's the problem. 11 squared, yes, is 121, but it can't possibly be -121. And the same holds true for -11. If you square -11, notice it's in parentheses again, just like -7 squared was earlier. You're going to get a positive only. There is no way that we can solve this particular quadratic equation and get an answer at all, because as it turns out, you cannot take, and there it is, the square root of x squared, the square root of -121. You cannot take, as I was saying, the square root of a negative number and get an answer. There is no real number that gives, or pardon, that can be multiplied by itself to produce a negative number. A negative radicand indicates that there is no real solution to an equation of that form. If we bounce back to this, for the sake of argument, if you did type in the square root of -121, again noting that we square rooted both sides of this equation, and yes, you could have done on the last problem as well, just for the sake of inspection, but also differentiability. I think they wanted you to kind of see how that would play out without square rooting. On this problem, they're asking you to test that theory. It doesn't work as they describe, but let's see the calculator prove that out. So your calculator is going to read, as it should, non-real answers. You cannot take the square root of a negative number and end up with any value that's real. It's said to be a non-real answer. All right, moving forward. Example 2. Solve equations of the form ax squared equals c. So I see here, as you can tell for part A, a similar type of thing, but with a not equal to 1, we're going to have to do a little bit more. 7x squared equals 112. So the first step should end up, as you can see here, is isolate the variable using properties of equality. So you want x by itself. So to start the process, we'll go ahead and divide both sides by 7. 112 divided by 7, 16. So x squared now equals 16. And because, as you're about to see, and you could see already a little bit, 16 is a perfect square. When you take the square root of both sides of your equation, the square root of x squared will simply be x. And not surprisingly, the square root of 16 should end up being 4. Now they're noting plus or minus 4, because as we discussed earlier, not only is 4 squared going to give us our end result as we hoped, as we checked, and as we checked earlier and check here now and hoped it to be, but so should negative 4 quantity squared. 4 squared and negative 4 squared check out to be the original problem on the right side there, 16. Okay, so you do need to have plus or minus. There are technically 2 answers to this problem, so please remember that. Part B, what are the solutions of the equation negative 3x squared equals negative 24? So we're going to go ahead and start to isolate the variable by using the property of equality again. We simply divide both sides, as you can see here, and divide by negative 3. So that then yields x squared equals 8. I'm taking the square root of both sides of the equation. As you can see here, solving for x will yield x equals plus or minus the square root of 8. Now if you did actually type this in, you'll find that, again, unlike, I guess you could say, from the last problem's perspective where this particular radicand was a perfect square, unlike that problem, if you were to take the square root of 8, it shouldn't give you a nice answer, and it doesn't. 2.828. This is an irrational number, while the square root of 16, because it is a perfect square here, ends up being a rational number. The square root of 8 is really all you can do there. Later on, we'll take a look maybe at breaking this down into something called factors, and then maybe you can continue with that simplification. But for now, plus or minus the square root of 8 should suffice. Okay, don't forget the plus or minus. Example 3. Solve again each equation, or solve the equations of this form though. Ax squared plus b equals c. So for this problem, we'll go ahead and take a look. Again, balancing the equation. Rewriting it though in the form of x squared equals a allows for this. You're shooting for that particular form essentially. So here it is again. We can add 5 to both sides. Of course, 3x squared now equals 27. Add 5. Next, we can divide by 3. Okay, if you divide both sides by 3, you get 9 there. Now the form is what we really were hoping it to look like, x squared equals a. And not only that, 9 is a perfect square, so that when you square root both sides, x squared equals 9 square root, so the square root of which is x, and then what? The square root of 9 is 3. Yet again, don't forget, plus or minus 3 must be, just like the other questions, must be part of your final answer. As a kind of follow-up here, it says you can use the properties of equality to write the equation as you see, 3x squared minus 5 equals 22, in the form of x squared equals a, right, like we did here with x squared equals 9. And since a is a perfect square, like we said, 9 happened to be, there are 2 integer answers. And again, like we said, the solutions are 3 and negative 3 of this particular original quadratic. Another thing that you can try, maybe on your own later, is to see if when you plug in 3, but also negative 3 here for x, see if that left side is in fact equal to 22. Again, plugging in those 2 numbers should bear that out. Try that on your own later. Okay, next example. Determine a reasonable solution. A cell phone tower has a guy wire for support as shown. The height of the tower and the distance from the tower to where the guy wire is secured on the ground are the same distance. What is the height of the tower? Okay. So we'll start as usual with formulating, but please take a look at the picture just to give yourself some perspective. These 2 distances are the same, and they've depicted it in this right triangle And more specifically, this, what we call to be a leg, is x, as is this leg, also x. Again, same distance. The guy wire, as you see here, we also call this the hypotenuse of this right triangle. You may remember that from past learning experiences in math. This particular length is 200 feet, and again, it's the hypotenuse of the right triangle. Again, what is the height of the tower? Let's formulate. So we're going to write an equation that relates the lengths of the sides of the triangle formed by the guy wire, the tower, and the distance on the ground from the tower to where the guy wire is secured. We're going to let x represent the height of the tower and the distance on the ground. The actual formulation here, as it turns out, does require some geometry, as it turns out. The Pythagorean theorem, which if you recall is a squared plus b squared equals c squared. Okay, this is a very important theorem in geometry, and in this particular case we have x, as it turns out, for a, x again but for b, so a squared plus b squared equals the hypotenuse c quantity squared, and it is known to be 200, which is nice. Again, use x in the Pythagorean theorem for the side lengths since the two lengths are the same. We're going to go ahead and solve for x, and in solving for x, some like terms are going to unfold. X squared plus x squared in particular add to 2x squared. 200 squared is 40,000, and we're going to proceed just like we did in the prior examples, essentially. Divide by 2, and if you divide by 2 you get x squared, and as you see, equals 20,000. Then you see here the square root of both sides. X squared ends up being the square root of which, is x. While here we've got some extra work to take a look at. Okay, there is a square root that kind of continues over all the way that you can't really see. But 2 times 100 times 100 technically represent the factors of 20,000. So 100 times 100, right, because that's technically 100,000. When you break it up as such, you can see then that you could take the square root of that pretty easily. The square root of 2, there's not much more you can do. Just leave that under the root, and there you have it. And the next step, x equals plus or minus 100 square root 2. Now we do have a bit of an issue though with the negative in front of the 100 root 2. Think about the actual application here in which you have an x here and an x there that, if you think about it, represent distances. So I'm not going to count the negative as an answer. When we proceed, the height of the tower must be positive, so the solution is 100 root 2, which is approximately 141, in this case 141 feet. You can actually finish this up, I would argue, very nicely simply by typing it in. And of course the square root of 2. Okay, I'm going to actually move in front of that and insert 100. So we have 100 root 2. No, you don't want negative technically because we're talking about distance, but in fact the decimal version of that root, 100 root 2, is in fact, as you see, 141.42. Okay, or they say 141 feet rounded. So please go ahead and take a look at any of the other questions where there's a try it that follows the examples. As we've seen in the past, this is sometimes a nice follow-up to our discussion.